Okay, so looking at this graph, the scatter plot, did you guys have the line there already? Oops. It's not supposed to be there. Justine, ready to go? Okay, guys? The scatter plot below compares students' absences from math class with the grade they obtain in the course. Describe the characteristics of a polynomial function that might be used to model this. So, what does this look like? A quadratic, a cubic, or a linear? Linear. Why does it look like linear? Yeah, it kind of it's decreasing in function, and it looks like it's decreasing at a constant rate. So decreasing at a constant rate. And so we could theoretically draw a line of best fit. Do you guys remember drawing lines of best fit? Where you want to have the same number of dots above the line as below the line. So mine should actually be maybe moved over a bit. Something like that. Okay? All right. So how do we get that line? Our calculator can actually find that perfect line. It takes all the data and it makes a line of best fit for you. And so we're going to learn how it's going to do that for us today. So that's why you need your graphing calculator. So a scatter plot is useful when looking for trends. If it follows a linear trend, then we're going to find a relationship, a linear relationship between the independent and dependent variable. So we're going to show you how to do that. When we're dealing with a scatter plot, if we want to find that linear trend, we have to use our graphing technology. So technology. And of course, in math, the only technology we really use is our graphing calculator. So when they say in your textbooks technology, they're talking about your graphing calculator. And we're going to do something called a linear regression. And it will help us determine the line of best fit, and it'll even give us the equation of that line. And that's what we're going to learn how to do today. So we can predict values that are not recorded or not plotted. Once you have your line of best fit or the equation, we can then predict values that are not recorded or plotted yet. Okay, using that relationship. So let's look at the next example. Oh, sorry, delete line. Don't look at that line. Okay, here's an example. And it says we're going to estimate the line of best fit and write in y equals mx plus b. So how many total points do we have? Count how many points we have. 15. So if we want to do a split, it's not an even number, so our split's going to be, might be right through one of them. So it either goes 7, 7 and right through one of them, or 8 above, 7 below, or 7 above and 8 below. So I'll help you a little bit. It helps if you have a ruler, because then you can kind of play around with that line. So this line, if we count, 1, 2, 3, 4, 5, 6, 7, 8, these ones seem like maybe they'll be the ones above, and these ones may be below. You don't have to circle them. It'll be ugly. So we want to kind of go halfway through, and halfway through kind of is like that. So if you had a ruler, it's easier to get your 8 above, 7 below type of situation. So we don't end up going through one of them, but that does leave 8 above, 7 below. So that's a line of best fit. It is an estimate, and your graphing calculator will do a perfect estimate for you. Okay? So if we write this equation in y equals mx plus b, how do we get our m value? What is that called? Slope, which is rise over run. So you need 2 points. So your graph should start at about 7.5 for y-intercept And it should go about down 1, right 1. Down 1, right 1. So what would our slope be if we're going down 1, right 1? 1 or negative 1? It's falling. It's negative 1, right? Down is negative, right is positive. What would our y-intercept be? Approximately 7.5. So our equation would be negative x plus 7.5. Right, this was our slope. Negative 1 here is our slope. But you don't have to write the 1. Okay, now it's really tough to do that all the time. So our calculators are going to do that for us. So let's grab your calculators and we're going to do the next problem with our graphing calculator. And you really need to practice these steps, so we'll write them down. Oh, we'll come back to this question and we're going to go straight into this one. Okay, Call Me Cellular is rolling out a new marketing plan that is aimed at families. Before finalizing the plan structure, the marketing department needs to know how the number of cell phones in a family is related to the size of the family. So you want to know how the number of cell phones in a family is related to the size of the family. So when you see is related to, your independent variable comes first. Dependent variables first, and your independent is second. And if you actually were to graph this, does the size of family affect cell phones, or do the number of cell phones affect the size of the family? Size of family affects how many cell phones they own. So the size of the family is your x variable, and the number of cell phones is your y. I don't like this question because usually, which should be on top? X, yeah. And normally that is the case. In this question, the data wasn't given that way. So be careful of that. And the information kind of tells you if you read that. And you can also figure yourself which one affects the other. So we're going to use our calculator to help us to plot this first. But before we do that, let's actually plot the data ourselves. So if x is family size, and y is going to be number of cell phones. And so can you now be very careful, because this is your x, this is your y. So when our family size is 5, we get a value of 2. Family size is 4 is 2. It's really backwards the way we think, so be careful. 4 and 3. 5 and 4. 3 and 1. 2 and 0. Yeah, that's okay. So then once it's the same, you just leave it. 4 and 2, 4 and 2, you don't do it again. 1 and 2. Oh, that was 2 and 1. See, it's backwards to my brain, because this is our x. 2, 1, 2, 2. 1, 1. My dots are ugly. 6 and 4. 4 and 1. 5 and 3. You girls getting this down? You got it down? So you should be able to do this yourself, though, with the data. Okay? Because this is our x, this is our y. 7 and 4. 2 and 1 is done. 2 and 0. 1 and 1. Does yours look like that? Okay, so does it seem like there is a trend here? Does it seem like the more people we have in our family, it does increase the number of cell phones? Yeah, it does seem like there is some sort of trend here. Okay, so how do we enter this in our calculator? Well, your calculator can make a plot just like this. So grab your calculators, and I'm going to write the steps all right here. Okay? Alrighty. So I need to cover this up. Is that okay? Okay, so the first button we're going to push is actually our stat button. So we're going to push stat. Okay, so that's not good. Stat. Okay. Make sure we're all on the same page. Don't want to lose anybody here. Good? Looks like this. Okay, we want to actually put these values into a list. So we want to push number 1 for edit. Okay, 1 edit. And then from here, enter L1 and L2 data. We did very similar in statistics, yeah. But the steps we're going to follow are going to be different. So okay, if you have does anyone have anything in their lists already? If you do, the easiest way to clear them is just go up to L1, push clear, back down, and it will be gone. Do not push delete, because then you will literally delete L1. You don't want to do that. Okay? So we're going to, now be careful, these are our x's. So L1 is x, and L2 will always be y. So let's start by entering my x values. You want to be very careful that you do not forget anybody. I'm entering in all my x values. Oops. Stat edit. I have to move this back over here now. Sorry. 1, 6, 4, 5, 7, 2, 2, 1. Yeah, you have to push enter. Sorry. Is this the first time some of you have entered things in lists? I guess the dash ones, if you came from dash 1, you've never worked. Well, that's the way the program is set up. And we did statistics in 20-2, and so yeah. Okay, 2. Now we can do our y values. Make sure it all lines up. You're fast. Some of you can be fast. Problem with being too fast, you can accidentally make a mistake. With an actually handheld calculator, I am faster. 4, 1. Okay, I'll bring out my calculator. I'll school you. Sorry. I'm a little competitive. Okay. All right, so you know, like, everything should line up. You're going to have an issue if it doesn't line up. We had 18 pieces of information. Does everyone have that in? Yeah. I have 19 pieces. Well, if you're on this part, it'll say 19. Okay, good. Okay? Anyone need help? We're good. Okay, so that was the first step. The next thing we need to do is turn our scatter plot on. So if we go to our graph, we won't be able to see anything right now. So 2 steps to do here. The first one is scatter plot is the yellow above y equals. So second, or it says stat plot. Second y equals. So second y equals. And you only have to do this once, and then it'll remain on. So I'll show you how to turn it off after. There's 2 ways to turn it on. One way is second y equals. We're going to push enter and enter, and that turns it on. Yeah, I know. It can do a lot, actually. Okay, does everyone have that turned on? So if you go to your y equals, this plot should be black. Just to check. So another easy way to turn it on is you could also push enter there, or push, right? That's another easy way to turn your plots on. The reason why I showed you the other way, in the other way, we can actually change, okay, I want to do L1 and L2. So if you have multiple lists, you can change which list rows we're looking at. You can change your dot type. So I want my markers to be pluses. I can make them circles. And then you can also, different types of graphs. And we want to do a scatter plot, and that's the first one. Okay. Now that that's done, the easiest way to see our graph is zoom stat. Zoom, and number 9 is stat. So what this will do is make sure you can see all your points in your scatter plot. So zoom 9, there they are. Okay, so that was to turn scatter plots on. Turns plots on. Zoom stat, which is number 9. Well, this is so you don't have to worry about your windows. Sometimes windows can be a very stressful thing, right? Figuring out where. Zoom stat, so you can see all your points on the scatter plot. All right, so now we want to actually figure out the regression equation. So how do we do that? So this is what's really important. Now that we have our scatter plot, I'm actually going to clear my y equals. There you go, so it's gone. How do we get that? We're going to find that in stat as well. Okay, so stat, and now we're going to go to calculate. I'm going to write this down. Stat, and then I went 1 over to calc. So the right arrow over to calc. Does that look like a, I don't know. Okay, well, which one do you think we're going to use? Let's take a look at what's there. One, variable statistics. We did that last year. We don't want that. Number 4, which is a linear regression. That's what we're going to do. And tomorrow, we'll get to work with quadratic and cubic. So push 4. Uh-oh, make sure there's nothing there. Push enter. And there you go. So the equation is ax plus b, or a is really like your slope, mx plus b. And here's the values. And I usually say answer to 4 decimal places. So I'm just going to write this down. We pushed 4, which was linear reg, and enter. Okay, so what's our equation for this line? Let's go to 4 decimal places. So our a value is 0.6139. 6139. X plus 4 decimal places for the b, 0.2596. Negative? Thank you. Minus 0.2596. Okay. Now, which variable was your y? What did y stand for? Number of cell phones. So you can actually replace this with a c if you want, and when you're writing your equation. And what was our x? Family size. So maybe we'd make that an f. So we can replace our variables if we want, so it makes sense in the context of the equation. The last part asks, the average family in Canada has 3 people. How many cell phones would you expect to find in an average Canadian family? We have an equation now. Could we use that? Plug in 3 into which value, x or y? We know there's 3 people. That would be the family size. That's our x value. Or we can use c. So c equals 0.6139 times 3 minus 0.2596. It's really, once you know the calculator, it's super easy. Yeah. Scroll up where? Here? Okay. I'll just move this over here. So we're going to type in that to our calculator. 0.6139 times 3 minus 0.2596. Okay, so approximately, did you get the same thing? 2 decimal places maybe? 1.58 cell phones on average. This question? So they said in an average family that has 3, so that's x equals 3, we just plug it into our formula. So this is our equation. So I made x 3. So I just typed it in. Okay? Easy? No? Do you want to try the next one on your own? Oh, let's go back up to number 2. Really quickly. Oh, same page. Same page. I'm going to go back up to number 2 here. Just really quick reminder, your x variable, is it independent or dependent? Independent. Yeah. And y is always dependent on x. Okay? And so in these statements, when it says is related to, is related to, is related to, if I said the distance traveled in a car is related to the average speed, the first is our dependent, and the second is our independent. Okay? So here, family size would be dependent, number of cell phones would be independent. You okay? Okay, last question, one more. Number 4. So here was all the calculator stuff that we did. So it's on here, but we just went through it. So, okay. Matt buys t-shirts for a company that prints art on t-shirts and then resells them. When buying the t-shirts, the price Matt must pay is related to the size of the order, right? You order more, you pay less. So, who's X, who's Y? Number of shirts would be your X, because the cost relies on how many you order. So Y, and usually X is first, Y is second. Like 99 times out of 100. Maybe even 999 times out of 1,000. Usually it's always X first, then Y in a table. Okay, so we're going to go to our tables, because we want to create a scatter plot. So stat and edit, number 1. Okay, we need to clear, so go up to L1, push the clear button and back down, and it will be gone. Easiest way. There is another way. If you go second mem, remember when you're resetting your calculator, there is a clear all list button. But it's easier just to do that, this. No, you won't. I'll be there to help you. So L1 is X. So we're going to enter in this data. 740. And make sure you push enter. I'm going to beat you, Jesse. Got to enter it in. Already? Oh, losing. Okay, so you know it should all line up. It's very important that you check over your answers, especially if this is a diploma question, because one number off here is going to affect your whole equation, which will affect all your other answers. So make sure you've typed in the right numbers, because it will give you the wrong answer. Okay, what do we do next? Zoom 9. Zoom 9. Our scatter plots are already on from last time, so we don't have to turn them on again. You got a calculator? Do you want to sit with Kayla? Put your desks together. Yeah. Work together. Is that okay? Okay. Okay, so there we go. We had 5 pieces of information. I see 5 dots. Does this look like a linear regression? Yeah, for sure. Okay, so now how do we get the equation? Stat. Okay. Then I have it down here. Then calc number 4. Boom. So over to calc, number 4, then enter. There is a way to get this on your graph, and I'm gonna show you that later. Okay, so there's our equation. Is that what you got? Woohoo! So let's write that down. It's good when it's the same. Okay, y equals 0.0065x plus 6.5. Okay. We go on. Everyone has that? Question? Anyone need help? You guys are awesome. Now, sometimes when you teach calculator stuff, remember when you guys were in grade 10? It's the last class. Oh. Okay, the next question asks, what does the slope and y-intercept represent of the graph? Okay. Now, it's not asking what is slope, the definition of slope. They're saying, in the context of this question, what does the slope and y-intercept represent? So our slope was negative 0.0065. What's the formula we use to get slope? Rise over run, or change of y over change of x. What was our y variable? What did y represent in the context of this question? So you can use your cost per shirt. And what did x represent? Number of shirts. So this would be the rate of change of the cost of your shirt, because your cost per shirt for every number of shirts, your unit for our slope is cost per shirt per shirt. It's kind of like acceleration, right? Meters per second per second. So it's the change of the cost of our shirts. Change of the cost of our shirt. There's a change in price per shirt, because the price is changing. Okay, what's the y-intercept represent in this? Was it 6.5? So the y-intercept represent. What's the unit for y? Cost per shirt, right? That was the y value. And so remember, our y-intercept is our fixed amount. It's not affected by our x. And so this would be like the initial cost of our graph. When we're buying no shirts, 0 shirts on our graph, the cost per shirt is $6.50. So this is the initial price of the shirt. Initial price before we buy any shirts. So it's initial price of a shirt. So they start off at $6.50 each, and then the price goes down as we order more. You with us, Sawyer? Yeah. Okay. Use the linear regression to extrapolate the size of order necessary to achieve $1.50 per shirt. So this equation here, what did our y represent? What was y? Let's give it a variable instead of y. C? I don't know. Why? Anybody? Let's look at our equation. Y was cost per shirt. So let's use C maybe. I'm going to use C. Okay? And X was the number of shirts, so maybe N. If you change your formula in terms of the context of the question, when they ask you application questions, they'll make a lot more sense. And you'll know, okay, they're giving me this variable. So in this question, it says, what size of order is necessary to get a price of $1.50 per shirt? Which value did they give us, C or N? C, the cost. And we want to find the number of shirts. Okay, let's solve for n. How do we do that? Get it by itself. First step, subtract 6.5, which gives us negative 5. So negative 5 equals negative 0.0065n. And then divide both sides by negative 0.0065. You calculate that? Tell me what to 2 decimal per, or let's say to the nearest whole number, the number of shirts. What does it give you for a decimal? Can I? 768 point. Okay, so 769 shirts. It's a lot of shirts, so you better be selling them, hey? Okay, I want to show you one quick thing. A little trick when you're doing your linear regression. If you actually want your graph to have the line of best fit in it, the way you could do that, when we go to Stat Calc 4, don't push enter right away. If you want this to go in your y equals, there is a way that it can do that. Okay? You'd have to push the vars button and then go to y variables and enter. So you're basically saying I want it to go into y1. So I'll show you that one more time. So vars, variables, I want a y variable. I want it to go into y1. Okay? So what that does when you push enter, it automatically puts the regression equation into your y equals. And so when you can graph it, it'll actually draw the line for you. Okay? So it does, when we do linear regression, okay, and you want to push y1. So how we get that? Vars. And then we go over to y vars. Okay. So vars, y vars, or variables. So variables, y variables. Number 1 for function. And 1 is y1. Let me see.
You put it and then
You have to go, so linear regression.
Okay. And then that's what comes up, and for like us to get
Store
it there.
bars, y bars, y1. So it'll store it in y1.
Okay.
I'm pretty sure. Yeah. Okay. And then it goes y. It's there.
Okay.
So if you have a different calculator, I can show you how to do it. Samara, can you put that away? Okay. Okay, so is there any other questions about this graph? So then if they ask you, say, what's the value at 3, for example, when x is 3, you can then go trace, you have to go down arrow to be on the line, 3, enter. No, I've done it. You have to make sure to go on to the right graph. Trace 3. Oh, this graph doesn't have a value of 3. That's why. But you can put in different values. Okay, so which will help you later on when you have more questions and tomorrow's homework and stuff too. Okay. Okay, so your homework for today is all of 5.3, so it's on page 122. You guys need to work together because the calculator?